So hello everyone, welcome to today's class. We're live. Welcome to today's class. Let's give them 2 minutes to join. Let's give others 2 minutes to join so we can kick off immediately. So today we're looking at trigonometry. Today's class we're covering everything concerning trigonometry. Everything concerning trigonometry. That's what we're looking at today. Alright, so under trigonometry, we'll look at the first two things as trig ratio and we'll look at what? Reciprocal ratios. Under trigonometry, we'll look at trig ratios and reciprocal what? Ratio. So if you can hear me, you can see me, let me know in the comment section because this is going to be an interesting class. So let's go. Let me just write it here. So now, let's look at sine, look at cos, and we'll look at tan. So take note, trigonometric ratio are based on right angled triangle. Trigonometric ratios are what? Based on right angled what? Triangle. That's the first thing you need to know. That trigonometric ratios are based on right angle triangle. Now, let me show you what a right angle triangle is. This is a right angle triangle. This over here is a right angle. And we know that for a right angle triangle, The angle here is what? 90 degree. The angle there is 90 degree. And the angle here is called theta. The angle here is called what? Theta. This part that is facing the angle theta, or this part opposite the angle theta, is called what? Opposite. While the diagonal length, which is the longest length, is called the what? Hypotenuse. It's called the hypotenuse. Then this part now, that's the base of the right angle triangle, is called adjacent. Please, you can write this down. So trigonometric ratio is based on this right angle triangle. Now, let's have another right angle triangle. It can be drawn like this. It can also be drawn like this. It's still the same thing. Whether the angle is facing this side or it's facing this side. Now, if the angle is here, that means here now will not be our what? Opposite. Are you seeing it? Now, this place from here to here will now be our opposite. Now, let's call this opposite side. Let's say our opposite is B. Now, this side now will be our what? Adjacent. And our adjacent, let's call it C. Then this side will be our what? Hypotenuse. And let's call it what? A. I seen it. So whether the right angle triangle is facing this side or facing this side, is the same thing. Where the angle facing the opposite is called what? Theta. It's called what? Theta. Now, let's look at something again. Let's look at how to find A, how to find B, and how to find what? C. That's what we'll look at now. How to find A, B, and what? C. Please let me know if the network is still on, because yesterday we had network issues. Okay, it's still on. Let's go. Now, let me clean this part. Now, to get sine theta, first of all, I want you to take note of this acronym. So, which means, so means what? Sine, which is opposite over what? Hypotenuse. Is cos, which is adjacent over hypotenuse, and tua is tan, which is what? Opposite over adjacent. So now, for SOH, that's so, we use it to get our what? Sine theta. And now our opposite, which is this, we said our opposite is B, so it will now be what? B over our hypotenuse, we say that our hypotenuse is A, so sin theta will be what? B over A. Then let's move to this other part, car. Car is to find what? Cos theta. To do that, cos theta is simply what? Adjacent over what? Hypotenuse. Now our adjacent we say is what? C. And our hypotenuse we say is what? A. So cos theta will be what? C over A. Next up we have 2, which we use to find what? This is cos theta. Next one is what? Tan what? Theta. 2, which is opposite over what? Adjacent. And we say that our opposite here is what? B. And our adjacent is what? C. So this is how we use SOHCAHTOA to get what? Sin theta, cos theta, and tan theta. Please take note of this. Very, very important. Very, very important. Now, sine is the short form. The full name is what? Sine. S-I-N-E. Similarly, cos is the short form. The full name is what? Cosine. And tan is the short form. The full name is what? Tangent. Tan what? Gent. So now I can clean this part and explain more for you. Let me clean it and explain more. Oh, man. Oh, because that is now what? Okay. Let me write it again. Hypotenuse. Hypotenuse. Now, this B over A is what? Sin theta is what? Opposite over what? Hypotenuse. Cos theta is adjacent over what? Hypotenuse. And tan theta is what? Opposite. I have that tan theta is what? Opposite over adjacent. So this is what they represent. This is what the word represents. So if we're given numbers, let's say our hypotenuse is equal to what? 5. Then our adjacent is equal to 4. And our opposite was equal to what? 3. And they say we should find sin theta, cos theta, and tan theta. Sin theta now will be opposite over adjacent. Our opposite is 3, right? So it will now be 3 over hypotenuse, that's 5. While cos theta will be what? Adjacent over opposite. Adjacent is 4 over what? Hypotenuse, which is 5. 4 over 5. And we have tan theta as opposite over adjacent. Opposite is 3. We have opposite as 3. And adjacent as what? 4. So this is how they will be represented. Now, there's another thing I want you to know. The inverse. The inverse of what? Sin theta, cos theta, and tan theta. Now, let's take the inverse of each of them. So, I'll clean this part. Now, if I clean this part, we will take the inverse of sine Now we have that the inverse. Now when we talk about inverse, we are simply saying like the reverse or the opposite of this. Now so sine theta, the inverse will be what? 1 over sine theta. Cos theta too, the inverse will be what? 1 over what? Cos theta. And tan theta, the inverse will be what? 1 over tan theta. But now this 1 over sine theta, this 1 over sine theta is known as cosec cant. Cosecant. And the short form for cosecant is what? CSC. Or let's just put it as cosec. This is the short form. Then for cos theta, the inverse, which is 1 over cos theta, is known as what? Secant. And we can put the short form as what? Secant. And we can put the short form as what? Sec. Then for the inverse of tan theta, which is 1 over tan theta, will be what? Cotangent. And we can put the short form as cot. So please take note of this. These are the inverse of what? Sin theta, cos theta, and what? Tan theta. So let's write them here in this form. So we begin here. And we are asked to find the what? Cosec of theta. Since it is the opposite of sin theta, using our what? SOHCAHTOA, we will now have that cosec will be what? Instead of it to be what? Opposite over hypotenuse, it will now be hypotenuse over opposite. Cosec will now be what? Hypotenuse over what? Opposite. And we are giving our hypotenuse as 5 and our opposite as 3. So to find sec theta, which is what? The opposite of cos theta, it will no more be adjacent over hypotenuse. It will now be hypotenuse over what? Adjacent, which is the reverse. Hypotenuse all over And we have our hypotenuse to be what? 5 over here. And our adjacent to be what? 4 over here. Next up, let's look for cot, which is the inverse of tan theta. Cot, or what? Cotangent. So we have our cot theta to be equals to, since tan theta is equals to opposite over adjacent, then cotangent, which is the inverse of tan theta, will be what? Adjacent over opposite. Adjacent all over opposite. And our adjacent is over here as 4, and our opposite is over here as 3. So this is how we represent the inverse of what? Sin theta, cos theta, and tan theta. So let's solve an example. Let us solve an example. Please, if you understood this part, let me know in the comment section before we proceed to the example. Please let me know in the comment section before we proceed to the example. Okay. Chisom, can you understand? Esther Ijoma. Hi, Esther Ijoma. Hi, Divine Chisom. Hi, Wally. Okay, let's continue, sir. Okay, so we can continue. All right. Let's continue to an example. All right, so we have an example. Example 1. Okay, while Tony said you understand. All right, let's proceed. So we're given both weights. We're given only the body is wet. The matter of time is behaving. Let me look for something. It is dry to clean very well. These are new markers I just got. So given a right angle triangle where opposite is equals to 6 cm and adjacent is equals to 8 cm. So they say we should find sine theta, cos theta, and tan theta. So what is the first thing we'll do when we see this type of question? So first of all, write out our solution. Next, they say we're given a right angled triangle. So let's draw our right angled triangle over here. And this is our theta, right? So, alright, we have our theta. And the angle opposite our theta is what? Opposite. opposite. And we are giving our opposite as what? 6 cm. The longest length, that's the diagonal length, is the what? Hypotenuse. And we're not giving any length for our hypotenuse. We're giving our adjacent as 8 cm. They say we should find sin theta, cos theta, and tan theta. So to find that, we need to know the knowledge of what? SOHCAHTOA. Well, now we want to find sin theta, and sin theta is opposite over hypotenuse, but we don't have the value for hypotenuse. So how do we find it when we don't have the value for hypotenuse? Now this is where the Pythagoras rule comes in. Have you heard of what Pythagoras? And Pythagoras rule is very simple. Pythagoras rule simply says that a square, remember our hypotenuse is a. Take note of that. A square is equals to what? B square plus C square. Where in this case our hypotenuse is A, let's say our opposite is B and our adjacent is C. You can change it. If you put here as A, that means, or you put here as C, let's say our hypotenuse, we put it as C, that means here we change to what? C square. And if you put here as A, that means here we change to what? A square. So the formula can change based on what you give your hypotenuse, your opposite, and your adjacent. So this is the basic knowledge of what? Pythagoras rule. So it will help us find what? A, which is our hypotenuse. So we have B as equals to what? 6. We have C as equals to what? 8. So let's substitute and get our values. So we have what? A square is equals to B square. B square is what? 6, so it will be 6 square plus what? C square, which is what? 8 square. So our A square will be equals to 6 square is simply 6 times 6, which is equals to 36, plus 8 square is what? 8 times 8, which is equals to 64. So our A square will be what? A square will be equals to 36 plus 64. I'll have 100. Now, A has a square, and we want to eliminate A square to just get A, which is our hypotenuse. So we simply what? Take the square root of both sides. Taking the square root of both sides, the square root sign will cancel the square, and we'll be left with just A as equals to the square root of 100, which is 10. Remember, they are all in centimeters, so it will be what? 10 cm. So our hypotenuse will be what? 10 cm. Please, are you following? Let me know in the comment section if you're following this explanation. Please let me know in the comment section if you're following this explanation. Daniel Nowoski, are you understanding or should I recap? Manuchim, right down sir, divine Chiso. Alright. While Itonyi, can you understand? Are you understanding what I'm saying here? How we got A? Does everybody understand how we got A? Please let me know in the comment section if everybody understands how we got A. Alright, so proceeding, we've gotten our value for A. Now, The question said we should look for sine theta, cos theta, and tan theta. And from SOHCAHTOA, we have that sine theta is equals to what? Sine theta is equals to what? Opposite over hypotenuse. And our opposite here is 6. Our hypotenuse is what? 10. So this is be our what? Sine theta. Next up, they say we should look for what? Cos theta. But before we do that, we know that here can be divided by what? 2 to get 3. And here can be divided by 2 to get 5. So our new value will be what? 3 over 5. So moving on to cos theta. Cos theta will be equals to what? Adjacent over hypotenuse. Adjacent is what? 8. Hypotenuse is 10. So if we divide 2 here, will give us 4. 2 here will give us 5. We're left with what? 4 over what? 5. And we have that tan theta is equals to opposite over adjacent. And our opposite here is 6. And our adjacent is 8. 2 into 6 will give us 3. 2 into 8 will give us 4. So we'll be left with what? 3 over 4. So we are done with this example. We've gotten our hypotenuse as 10. We've gotten sine theta as 3 over 5. We've gotten cos theta as 4 over 5. And we've gotten tan theta as 3 over 4. Very simple. Very, very simple. So now, the next thing we need to do is take another example. Let's take another example very fast. Let's take another example. Going to clean this. Okay. Let me just clean this part. Clean the values. Let me clean the values only. So the next example. The next example says example 2. Example 2 says given sine theta is equals to 5 over 13. So we can find cos theta and tan theta. So in this example, we're only giving sine theta as 5 over 13. We are asked to find cos theta and we are asked to find tan theta. So what's the first step? Solution. My first step will be to represent this in form of SOHCAHTOA. Now, this is sine theta, and sine theta is what? From SOHCAHTOA, we have sine theta as opposite over hypotenuse. So opposite should be the top, and hypotenuse should be the what? Bottom. That's the numerator and the denominator. So we have opposite as 5, so we'll write it here. And we have hypotenuse as 13. We'll write it here. So now what we don't have is our what? Adjacent. And we need our adjacent to find cos theta. Because cos theta, which is car, is what? Adjacent over what? Hypotenuse. So now we'll go back to our Pythagoras rule. Which we say a squared is equals to what? B squared plus C squared. Now we are given A, we are given B, but we don't know what? C. So let's find C. To find C, we'll simply make C the subject of the formula. And we make C the subject of the formula, we have that what? C squared is equals to, we take b to this other side, it will now be negative, it will now be what? A square minus b square. So are you seeing it? A square minus b square. So from this formula, we'll be able to find what? C, which is our adjacent. So let's have our c squared to be what? Equals to A is what? 13. So 13 square minus B is 5. 5 square. So 13 square, c square will now be equals to what? 13 square is simply what? 13 times 13, which will give us 169 minus 5 square is what? 5 times 5, which will give us 25. So we'll have c square to be equals to 169 minus 25. We'll have our answer as what? 144. Now, to eliminate this square sign, we'll simply take the square root of both sides. So this square root will cancel this square, and c will be equals to the square root of 144, which is what? 12. So we've gotten our value for c, which is the adjacent, as 12. Now we've gotten our adjacent, we can now look for what? Cos theta. Now, for cos theta, from this SOHCAHTOA, we know that cos theta is equals to adjacent over hypotenuse. So we now have what? Cos theta, which is what? Adjacent over hypotenuse. So we now have cos theta to be equals to, adjacent is what? 12 over hypotenuse is what? 13. So this is our value for what? Cos theta. Next one, they say we should look for what? Tan theta. And we know that tan theta from SOHCAHTOA is what? Opposite over adjacent. So we'll have that tan theta is equal to opposite over adjacent. And we will now have our final answer as tan theta to be equals to, opposite was given as 5 and adjacent as 12. So our final answer for tan theta will be what? 5 over 12. And for cos theta to be what? 12 over 13. So we are done with example 2. Very, very simple. So now let's go to example 3 and solve questions on example 3. Now example 3, we'll be looking at secant, cosecant, and cotangent, which is the inverse of sine theta, cos theta, and tan theta. So we'll solve an example on that. Let's go. Please, if you understood this second example, let me know in the comment section. If you understood this second example, please let me know in the comment section so we can proceed. Alright, let's go. Another example. So example 3. Example 3. So now example 3 says, what the Tony says, please, I don't understand. What the Tony says, can we leave it in decimal? Okay, you can leave it in decimal. You can leave it in decimal if you want to leave it in decimal. But if you want to leave it as a fraction too, you can leave it as a fraction. So Wally Tony, please, which part did you not understand? Was it in example 2? Which part did you not understand? Let me know. I will explain for you. So this is example 3. Jenny Sony, welcome. Where are you from? I'm from Nigeria. River State, Port Harcourt to be precise. Alright, let's go. Example 3 says, for example 3, this will be based on sec, cosec, and cot. Please take note of this. These are the reciprocals. The reciprocals of sine, cosine, and tan. This is what? For what? Cos. This is for what? Sine. And this is for what? Tan. So the opposite of cos will give us sec. The opposite of sine will give us cosec, and the opposite of tan will give us cot. So please take note of that. Please take note of that. Very, very, very important in trigonometry. Very important. I cannot overemphasize on it, but please take note of it. So let's solve example 3. Example 3 says, find, okay, from earlier, that's from example 2, from earlier, we had sine theta to be equal to 3/5, cos theta to be equal to what? 4/5, okay? 4/5. And we had tan theta to be equal to 3/4. This was from example 1 earlier. Our solution from example 1 earlier. So now, they say we should find cosec theta, sec theta, and what? Cot theta. Full stop. Now, this question is very, 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 very easy. This question should not take more than 1 minute to solve. So our solution, even we say 1 minute is too much, 30 seconds. Since we know that it's a reciprocal, so for cosec, we said cosec is for sine. The inverse of what? Sine is cosec. So we just write that cosec theta is equal to what? 1/what? Sine theta. So we have sine theta as what? 3/5, right? So it will now be 1/3/5. And 1/3/5 is simply what? 1 divided by 3/5. If we transverse it, it's now be what? 1 times what? 5/what? 3. And 1 times 5 is what? 5/3. So very, very simple. You will not even waste up to 1 minute to solve this question. The inverse of sine theta is what? Cosec. And we have sine theta as what? 3/5. So it will now be 1/3/5, which is the same thing as 1 divided by 3/5. To remove this division sign, you what? Flip it. So it will now be 1 times 5/3, which will give us 5/3. 1 times any number will give us what? That number. So let's go. We are gotten for cosec. They say we should find sec theta. Similarly, for sec theta, my solution will be what? Sec theta now, we are talking about cos, and we have cos theta as 4/5. Sec theta is 1/cos theta, and we have cos theta to be what? 4/5. So it will be 1/4/5. You do the same thing, which is also 1 divided by 4/5. To eliminate this division, we now have what? 1 times what? 5/4. 1 times any number will be what? See the number. So we have our final answer as 5/4. And for cos theta, which is the inverse of what? Tan theta, that is 1 over tan theta. So we have our answer to be what? 1 over, what is our tan theta? See our tan theta over here, 3 over 4. So I'll have my answer to be what? 1 divided by 3 over 4, which is what? 1. Now to eliminate this division sign, we'll flip it. So it will now be 1 times 4 over 3. And 1 times any number will give us that number. So we'll have what? 4 over 3. So we've gotten our answer for what? Cosec theta, sec theta, and cot theta. Let me put the theta. Very simple. Please, if you understood this explanation, let me know in the comment section. Let's proceed to example 4. If you understood this, let me know in the comment section. So proceed to example 4. Alright, so we are moving to example 4. It said I should please increase my voice a bit. Emmanuel Ola Dotun said, sir, please can you talk loud a little bit? So I'm going to be increasing my voice. We are solving example 4. Let's solve example 4. So still on sec, cosec, and cot, example 4. The board is wet, let me clean it. Alright. So example 4 says tan theta is equals to 7 over 24. We should find sec theta and cosec theta. So we are given our tan theta as 7 over 24. And we are asked to find sec theta and cosec theta. Now, from SOHCAHTOA, let's bring our mind back to SOHCAHTOA. So our solution will be like this. This is how my solution will be like. Solution. First of all, what is tan theta? Tan theta is simply what? From SOHCAHTOA, opposite over adjacent. We know that tan theta is what equals to opposite over adjacent. And we have 7 over 24, so which should be what? 7 over 24. Now that means our opposite will be what? 7, and our adjacent will be what? 24. Now, we don't have our hypotenuse, and we need our hypotenuse in order to find cos theta and sin theta. And when we find cos theta and sin theta, if we take the inverse of sin theta, we will get what? Cosec theta. And if we take the inverse of cos theta, we will get sec theta. So now the first step is to find this hypotenuse. Now from our Pythagoras rule, we know that from Pythagoras rule, we know that a square is equals to b square plus c squared. But this time we are not given a square, so we are looking for a square. So it's already the subject of the formula. So we input the value for b square and c square. Now we now have that what? A square is equals to, our b here is opposite, which is 7. So 7 square, that's b square, plus c square, which is adjacent 24, plus 24 square. So we'll have that a square will be equals to 7 square is 7 times 7, which will give me 49, plus 24 square is simply 24 times 24, which will give me what? 5, 7, 6. Now we now have a square is equals to what? 49 plus 5, 7, 6, which will give us what? 6, 2, 5. Now to eliminate this square sign, you simply take the square root of both sides. Now the square root will cancel the square and we'll be left with a as equals to the square root of 625, which is what? 25. So we have gotten a, which is our hypotenuse, as 25. So we are done with step 1. Look for the hypotenuse. Now we will move over to step 2. For step 2, very simple. Now sec theta is simply what? The inverse of what? Cos. That's 1 over cos theta. And we know that cosec is equals to what? The inverse of sine, which is what? 1 over sine theta. 1 over what? Sine theta. So now, if we know this, sec theta as 1 over cos theta and cosec as 1 over sine theta, so we now have that what? To find sec theta, we now have equals to what? 1 over cos theta is what? Cos from SOHCAHTOA twice, adjacent over hypotenuse. Our adjacent is what? 24. So we have 24 over hypotenuse, which is what? 25. So this is the same thing as what? 1 divided by 24 over 25. Now if we simplify, to eliminate this division, we will now have that sec theta is equals to 1 times what? 25 over 24. Because to eliminate this division, we will simply flip the values. So 1 times any number will now receive the number, which is what? 25 over 24. So this will be our value for what? Sec theta. Please hope you are following. We know that sec theta is simply 1 over cos theta. And for cos theta, we know that cos theta is equals to adjacent over hypotenuse. And our adjacent was given as 24. Our hypotenuse was given as 25. So we simply what? Substituted in cos theta as 24 over 25, then simplify to get what? Sec theta. Similarly, for cosec theta, which is what? 1 over sin theta. 1 over sin theta is simply from SOHCAHTOA, opposite over hypotenuse. Our opposite is what? 7 all over our hypotenuse, which is 25. So we'll have that cosec theta is equals to what? 1 divided by what? 7 over 25. Now, to eliminate this division sign, we'll now have that cosec theta will be equals to what? 1 times what? 25 over 7. It will change, it will flip, to change this division to multiplication. And we'll now have our final answer to be what? 1 times 25 over 7 as what? 25 over 7. Please, someone asked in the comment section, can we leave our answer in decimal? Can we leave our answer in decimal? Yes, it's your choice. If you want to convert it to decimal, you are still correct. If you want to leave it as a fraction, you are still what? Correct. So we are done with example 4. Please, if you don't understand, let me know in the comment section. If you understand, let me know. Say proceed, so we can proceed to the next thing we have for today. Should I proceed? Yes, sir. Alright, Chisom Divine said yes sir, we can proceed. What Atonye said hi sir. Okay, so we can proceed. Now, we'll be looking at what we call special angles. Special angles. We'll be looking at what we call special angles in trigonometry. We have what we call special angles in trigonometry. Special angles. Special angles. We are still under trigonometry. So we're looking at special angles. These are angles that are very special when it comes to trigonometry. Special angles. So when we talk about special angles, we are talking about angles like 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. These are all special angles you need to be aware of. Now, take note. These angles have a fixed trig value. These angles have a fixed trig value, and you need to memorize them because it will help you to solve faster. Like you'll be very fast when you're solving using these angles. So now I'll draw a table, and from that table I'll be giving you the angles for each of them, for sine, for cosine, and for tan. So let's draw our standard table. Standard table. Please memorize this. You need to memorize this. This is our standard table. Please memorize this. Now, for the standard table, we have degrees, we have sine theta, we have cos theta. Please, I need to memorize this. Know this very well. Look at it and know it for your JAMB exam 2026 and beyond. 2027 they will still bring, 2028 they will still bring it out, 2029, 2030. So just please memorize this standard table I'm about to give to you. So here we have 0 degree. The next one, we have 30 degree. The next one, we have 45 degree. The next one, we have 60 degree. And finally, we have 90 degree. Alright, so now sine theta, we know that theta represents degrees. Anywhere you see theta, you input the value of this degree inside it. So sine theta for sine 0 degree, for sine 0 degree, we have what? 0. For cos 0 degree, we have our answer to be equals to what? 1. And for tan 0 degree, tan theta, that is tan 0 degree, we have what? 0. So anywhere you see sine 0, know that is 0. Anywhere you see cos 1, cos 0, know that is 1. And anywhere you see tan 0, know that is what? 0. Next up, sine 30 degree is simply what? 1 over 2. 1 over 2 for sine 30. Now, for cos theta, which is cos 30 degree, we'll have what? Root 3 over what? 2. And for tan 30 degree, we'll have 1 over root 3. Please memorize this, very important. Moving on, we have that sine theta, that is sine 45 degree, will give us root 2 over 2. And we have that cos theta, which is cos 45 degree, will give us also root 2 over 2. And we'll have tan theta, which is tan 45 degree, will give us what? 1. Because if you divide this divided by this, you get 1. I seen it. Very simple. Very, very simple. This one too, if you watch, if you do sine divided by cos theta, you will still get 1 over 3, because this divided by this will now turn to what? 2 over root 3. 2 will cancel 2, so we'll now be left with 1 over root 3. And similarly, if you do 0 divided by 1, you get 0. So the logic is, once you know sine theta as the sign of the angle, you know cos theta, sine over cos will always give you what? Tan. So you just need to memorize. If you memorize, you just memorize this cos and sine. To get the theta will simply be sine over cos. You will not stress. So let's go. For 60, sine theta will be what? Root 3 over 2. Root 3 over 2. And for cos 60 degree will be what? 1 over 2. I seen it. So now if you do 3 over 2 divided by 1 over 2, you will have what? Root 3. Root 3. Because this will now become 2 over 1, 2 cancel 2, and you left with what? Root 3. Now, sine 90 degree will give you what? 1. And cos 90 degree will give you 0. Now, 1 divided by 0 will be undefined, so it will give you what? Infinity. Positive infinity. So this is how the standard table looks like. If you look at it closely, you observe a pattern. Now, sine 0 was 0, cos 0 was 1. But look at cos 90 is 0, sine 90 is what? 1. I seen it. So if you're memorizing, let me give you a strategy. If you're memorizing it, once you get sine 0, cos 0, when you talk about 90, you simply what? Change them. Same thing with sine 30 degree. Sine 30 degree is what? Half. Cos 30 degree is what? Root 3 over 2. Now, when you come to what? Sine 60 degree, you are having root 3 over 2. And when you come to cos 60 degree, you are having half. So if you have this 30 degree, you simply what? Change it to get what? Cos. Now, sine 45 is the same on both sides. Cos 45 is still the same, root 2 over 2. Same thing here, root 2 over 2. So if you can memorize this one and this one, you'll be able to get every other thing in the table. If you can memorize these 3 and these 3, you're able to get every other thing in the table. Because to get these ones, you just need to get sine and cos and divide the sine by the cos to get the tan values. Now, sine 0 degree is 0. Sine 30 degree is 1 over 2. Sine 45 degree is what? Root 2 over 2. Now, you know cos, the same thing. Cos 0 degree is 1. cos 30 degrees root 3 over 2, and cos 45 degrees root 2 over 2. Now when you go to 60, which is 2 times of this one, you take this to this other side, you bring this one. You can see you're cross multiplying them. Now when you go to 90 degree, you do the same thing. Take this one to this side, then take this one to this side. Very simple. So please memorize this table. Please memorize this word table, and you will find it very important. Very, 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 very important. Alright, so let's proceed. Let us what? Proceed. Okay, so let's solve an example before we proceed. Please, if you understood this table and the explanation of this table, let me know in the comment section. Please let me know in the comment section, because we are about to solve an example on it. Alright, let me see what they said in the comment section. Okay, while Itoye said, I understand. Chisom Divine said, proceed. Alright, so please, in case you're new to this channel, don't forget to subscribe and smash the like button. Smash the like button, please. Let's go. Let's solve an example under special angles. Okay, let me clean these parts. An example. So the example says, evaluate sine 30 degree plus cos 60 degree. Now, this is how the thing will come out in your JAMB. Very simple like this. All you need to do is to recall from our standard table. We know that sine 30 degree is the same thing as what? Cos 60 degree. And we know that sine 0 degree is the same thing as what? Cos 90 degree. We also know that sine 45 degree is equal to the same thing as what? Cos 45 degree. I see the pattern. Very similar pattern. Sine 30 degree is cos 30 degree. Is cos 60. Sine 0 degree is what? Cos 90 degree. Sine 45 degree is what? Cos 45 degree. I see it. The similarities between both of them. So you don't need to panic. You just need to recall. Now, we have that sine 30 degree is equal to what? 1 over 2. Sine 0 degree is same thing as what? Cos 0 degree, cos 90 degree, which is same thing as what? 0. And we know that sine 45 degree is same thing as cos 45 degree, which is what? Root 2 over what? 2. Now, we are done with that. Okay, now let's just do for cos 2. Cos 30 degree is the same thing as what? Sine 60 degree. Take note of that. And cos 0 degree is the same thing as what? Sine 90 degree. And we know that cos 45 degree is the same thing as what? Sine 45 degree. We've written that one already. So now, for cos 0 degree, which is sine 90 degree, is equal to what? 1. And for cos 30 degree, which is what? Sine 60 degree, is equal to what? Root 3 over 2. Are you seeing it? So now they say we should find sine 30 degree plus cos 60 degree. We know that sine 30 degree is what? 1/2 plus cos 60 degree is still the same thing as 1/2. So if we add both of them, we take the LCM, which is 2. 2 divided by 2, 1, times 1, 2, plus, are you seeing it? Two divided by 2, 1. Okay, no, sorry. What did I do here? 2 divided by 2 is 1. 1 times 1, 1. Sorry. 2 divided by 2 is what? 2. 1. 2 divided by 2 is what? 1. 1 times 1 is 1. Which will now be what? 2/2. 2 divided by 2 will be equals to what? 1. So this is our final answer. Sorry for the miscalculation here. So this is what we are going to have when we add sine 30 degree plus cos 60 degree. Very simple. The moment you can recall this thing now, you can solve any question, no matter how they twist it, you'll be able to detect. And it's very simple to remember it. Just remember one, you have remembered the other ones. So let's proceed. Now, let's take another example. If we are also asked to evaluate, let's say we are asked to evaluate tan, which one should we use? Okay, tan 45 degree divided by, I just want to choose a random angle so I will be able to understand. Divided by what? Sine 60 degree. Now, if we have to evaluate this is for I, this is for II, so this is I. Now, II. Now, to get tan 45 degree, we know that tan is equals to what? Sine over cos. This is a relationship. I'll show you. Now, for sine, we have sine 45 as what? Equals to root 2/2. And cos 45 as the same thing as root 2/2. So root 2/2 divided by root 2/2 will give us what? 1. So we now have that tan 45 degree is what? 1 divided by what? Sine 60 degree. Let's look for sine 60. See, this is our sine 60, which is what? Root 3/2 divided by what? Root 3/2. I see the way I'm following it gradually. Next, to eliminate this multiplication sign, we now have 1 times what? 2/3, which will give us what? 1 times 2 is what? 2/3. So this will be our final answer for what? Tan 45 divided by what? Sine 60 will give us 2/3. Then sine 30 plus cos 60 will give us what? 1. Very simple. So let's move on. Next up, we'll be looking at trigonometric identities. Please, if you understood these examples, let me know in the comment section so we can proceed towards trigonometric identities. Let me know in the comment section so we can proceed to trigonometric identities. Are you there with me? While the toy said, I don't understand, please can you come again? Alright, let me come again. Well, it's not going anywhere in the first place, but I'll be fast this time. Sine 30 degree from our table, if you look at the table that you wrote down in your notes, is equals to half. Cos 60 degree from the table is equals to also half. Now they say we should add sine 30 plus cos 60, which is half plus half. And our answer was equals to what? 1. It's very simple, you don't need to think too much. Tan 45, look at the table. What do we have as tan 45? We have it as 1. Sine 60, look at the table. we have it as root 3 over 2. And they say we should divide it. So dividing it, 1 divided by root 3 over 2 will now give us what? 2 over root 3. Let's go. We are done with special angles. Just look at it, read it over and over again. It's self-explanatory. It is not rocket science. It's not going to be that hard like that. When we get to the hard one, I'll tell you so you calm down and also understand. So let's move on. Let's move on. Trigonometric identities. Trigonometric identities. So now, for trigonometric identities, you need to understand this. These are equations that are always true. For trigonometric identities, these are equations that are always true. Any equation under trigonometric identity that you see, just believe it. It is what? 100% true. So now, I'll give you 3 of them that you should know at all times. 1. The first one is called the what? Pythagorean identity. Pythagorean identity. And for this one, we have that sine square theta plus cos square theta is equals to what? 1. Sine square theta plus cos square theta is equals to what? 1. For the second one, we have the tangent identity. Tangent identity. And for the tangent identity, we have that 1 plus tan square theta is equals to what? Sec square theta. Please take note of this. 1 plus tan square theta is equals to what? Sec square theta. The third one is called cotangent identity. Co what? Tangent identity. And for the cotangent identity, that is cot. The short form for cotangent is what? Cot. We have 1 plus cot square theta. Cot is same thing as what? Cotangent is equals to what? Cosec square theta. Cot is same thing as what? Cotangent, and is equals to what? cosec square what? Theta. Please, you need to write this down and look at it anytime you look at trigonometric identities. The three of them are very, very, very important. Now, with this idea, we are going to what? Solve problems. With this simple idea, we are going to what? Solve simple what? Problems. Alright. Please write. If you have any question, let me know in the comment section before we proceed to solving an example on this. Let me know in the comment section if you have any question, because we are about to solve a problem. We are about to solve a problem. Please look at this. We are going to use it and solve problems now. So please look at it. Write it down. In fact, write it down. Write it down. We'll solve two examples on this. Solve two good examples on this. Alright, I believe you have all written this down, so I can clean the board. So let's proceed. Should I even clean it? Like, I won't leave it. Okay, let me clean it. Since you have written it down, let me clean it. I've written it down already, so let me clean it. So let's solve an example. Example 1. Okay, let me check what's going on in the comment section. Alright, hope you're following. I just joined the class. Please, can you explicate? Are you trying to write explanate? Omo Sheyi, Shegu, Elijah. You see, I just joined the class. Please, can you explain it one more time? Okay, when I solve this example now, you'll be able to what? Understand it. You'll be able to understand it. Let's solve this example together so you'll be able to understand it. After the class, you can still watch the video again for better understanding. For what? A better what? Understanding. Alright, example. The board is still wet. So, for example, which example are we on now? Is it 6 or 7 or 5? Okay, we've lost count of the example, but okay, let's take an example. They say if sine theta is equals to what? 3 over 5. If sine theta is equals to what? 3 over 5. We should find what? Cos theta. Find cos theta. So now, how will you just give us a question like this? That's the first thing you should ask yourself. Because cos theta and sin theta are related, so our solution will look like this. First of all, before you start solving, I need you to recall this. Recall that what? Sine square theta plus cos square theta is equals to what? 1. This is the first thing you need to recall from the relationship between what? Sine theta and what? Cos theta. That's the Pythagorean identity. Pythagorean identity. Once you recall this, now they give us sine theta as 3 over 5. Therefore, sine square theta will be what? The square of what? Okay, let me write it here. Let me write it here. Sin theta is equals to what? Sin theta is equals to 3 over 5. So sin square theta will be what? 3 over 5 square. Are you seeing it? Now, first of all, we are looking for cos theta. So if it's like this, we need to what? Rearrange the equation. When I say we need to rearrange the equation, it simply means we need to put it in a way that cos will be on its own. So rearranging this equation, we'll take this sin square theta to this other side. So we now have what? Cos square theta is equal to 1, which is this. Then this will now change to negative minus sine square theta. So let's solve from here. So this now, let's just write it from here. Let's solve from here. Since you're looking for cos, let's just solve directly. So cos theta will now be what? Cos square theta is equal to what? 1 minus sin square theta, which is sin theta times sin theta, which is what? Our sin theta is 3 over 5, which is 3 over 5 square, which is 3 over 5 times 3 over 5. Now we have done this. The next step is to what? Break it down. Now we'll simplify it. Cos square theta will be equal to what? 1 minus 3 square will give us 3 times 3, that is 9, over 5 square will give us 5 times 5, that is what? 25. So this is what we'll have. So now we'll have our final answer, cos what? Square theta to be what? 1 minus 9 over 25. 1 minus 9 over 25. Let me do it for you here. Take the LCM, which is 25. 25 divided by, this is over 1. So 25 divided by 1 is still going to give you 25. 25 times 1, 25. Minus 25 divided by 25 is 1. 1 times 9, 9. So you'll be left with what? 25 minus 9, which is 16 over what? 25. So our final answer will be what? 16 over what? 25. But now, they said we should look for what? Cos theta. Cos theta. But here they give us what? Cos square theta. Now, to get cos theta, we simply what? Take the square root of both sides. So this square root will cancel this square sign, and we'll be left with what? Cos theta as equals to the square root of 16 is what? 4 over the square root of 25 is what? 5. So this will be our final answer for what? Cos theta from the question. So we have solved this question. Very simple. The first step is to what? Get the relationship between sin theta and cos theta. Next up, you square sin theta to get what? Sin square theta. You make cos theta, cos square theta the subject of the formula because you are looking for cos theta. So when we make cos square theta subject of the formula, we take sin square theta to this other side and become negative. So you have 1 minus sin square theta. Next up, you substitute in your values. For sin square theta is simply what? Sin theta all square. This is what we got. So we took 3 square was 9, 5 square was 25. Now we now did 1 minus 9 over 25. 1 minus 1 over 9 over 25. 1 is simply as 1 over 1. So we take the LCM as 25. We did 25 divided by 1 is 25 times 1, 25. Minus 25 divided by 25, 1. 1 times 9, 9. 25 minus 9 gave us 16 all over what? 25. So we got this as our value for what? Cos square theta. To eliminate the square sign, we simply what? Took the square root of both sides of the equation, and we found out that cos theta is equal to what? 4 over 5. Very simple. So let's solve one more example. Let's solve one more example. Then after that example, I'll give you the graph of, I'll show you what a sine graph equation looks like and what a cosine graph equation graph look like, and what a tangent graph look like. Then after that, we'll look at the sine rule or the laws of sine. They will call it a what? A day. So we still have like some other things to do. We have so many things to do today. Let's go. We have so many things to do today, and we are making good progress. We are making what they call good progress. Very, very good progress, and I'm happy. All right, let's go. So example 2. Example 2. If you have any question, this is my WhatsApp number. You can text me on WhatsApp 8126 +234 81263 88049 or 08126388049. So let's solve another example. Still on trigonometric identities. Example. Alright, so this example, we are given 1 minus cos square theta all over what? Sine square theta. 1 over cos square theta all over sine square theta. And we're asked to what? Simplify it. Let us simplify and see what we get as our final answer. So solution. Now, like I told you, the first thing is to what? Record your relationship. Now, this anytime you see just cos and sine, you know that it's a what? Pythagorean relationship. So let's recall it. Sine square theta plus cos square theta is equals to what? 1. So now we've recalled it. But now, this our numerator is looking familiar. There is no sign, so that means it's put in terms of what? Sine square theta. So now let's make our numerator in terms of what? Sine square theta, so that when we divide, we'll get a value. So to do that, from this relationship, we know that what? Sine square theta is equals to what? 1, take cos to this other side, minus what? Cos square theta. So now, we have our what? Numerator, 1 minus cos square theta, which is equals to what? Sine square theta. So now, our solution will be equals to what? In place of this numerator, we'll substitute it for what? Sine square theta. All over what? Our denominator, sine square theta. Our answer will be what? Sine square theta into sine square theta will give us what? 1. So this is our what? Final answer. Very, very simple. This will take you 1 minute to solve. Just 1 minute to solve. So now, let's just look at some graphs. Let's look at what? Some graphs. Now, we'll talk about, let's clean this, we are done with this. Let's look at something else. The graph of trigonometric function. Graph of trigonometric function. That's what we call this subtitle. Graph of what? Trigonometric function. So we call it what? graph of trigonometric function. Now, for the graph of trigonometric function, take note, please take note. Trigonometric graph shows how sine, cos, and tan change with angles. So, trigonometric graph shows how what? Cos, sine, and tan changes with respect to what? Angles. Please write this down. Now, from this thing, the key things you need to understand is what? The key things you need to understand. The key things to understand. Key things to understand. The first thing to understand about the trigonometric graph is what? The shape of the graph. Always look at the shape of the graph. Next up, look at how many times the period repeats. That is how it what? Repeats. And the final thing to look at is what? The maximum value and the what? Minimum value. The what? Maximum and minimum values. So once you know the shape of the sine graph, the shape of the cos graph, the shape of the tan graph, you know how many times the period occur, and you know the maximum and minimum values, you can now be able to identify which of them, which of the graph we are considering. So now let's look at each of them one after the other. Let's look at each of them one after the other. So we look at them one after the other. So let's start with the sine graph. The what? Sine graph. Now, for the sine graph, we have y is equal to what? Sine x. Y is equal to what? Sine x. And the sine graph can be very simple, or what I call it tricky. Now let me draw it. Look at how it is going to look like for the sine graph. Here is 1. Here is minus 1. Now we have angles divided at each point. Let's go. So this is what? 30 degree, 60 degree, 90 degree, 120, 150, just like that, up to 120, 150, 180, 210, 220, 270. Let me just write it. 120 degree, 150 degree, 180 degree, 210 degree, 240 degree, we have 270, we have 300 degree, we have 330 degree, we have what 360 degree. So these are the angles theta. Now this graph will go like this. You have points, different points, different points to be going, different points, just like that. Now all these points, okay, let's go under 30. You have a point here, under 60 you have a point, under 90 you have a point, under 120, under 150, under 180, under 210, under 240, under 170, under 300, under 330, and under what 360. So this is for the what sine graph. It starts from what +1, and at each angle, the angle is what, the scale is what 30 degree will represent what 1 unit for the what theta angle. That's the theta angle, the x angle. Then for the y angle, we are using 1 unit represents 1 unit for the y angle, y axis. So this is the y axis, the y axis. So now for this graph, you will now trace it. Observe, starting from here, you will be joining them, joining the points, and this is how what our sine graph will look like. So y will be what sine of what x. That's what we get as our y value, the sine of x. So if x is what 30 degrees, so sine 30 degrees, we'll get y value. Anything we get for what the sine of x, we use to get our what y value. So take note, this is how the what sine graph looks like. Now that's for the sine graph. The cosine graph can be very what tricky. Okay, let me draw the cosine graph. Should I draw it on it, or I should clean and draw it again? I cannot clean it and draw it again. Let me just write it here. For the cosine graph, this is for the sine graph. Now for the cosine graph, let me draw it on this. The cosine graph we have that what y is equals to what cos x. Now if you want to represent that, the cosine graph start from here, this 0, to have another point at this 30. Are you seeing it? Until it gets to this 180, to be having points 150, 120, 60, 90. Then it will now go again from here until it comes at what 360. That's, we will keep going, keep going, keep going, keep going, keep going, and keep going. So the cosine graph will be something like this. So this is going to be our what cosine graph, starting from here, which is equals to what y is equals to what cos x. I seen it. So this is our cosine graph, which is what cos s, and this is our sine graph. I see the difference. I see their waveforms. For the sine graph, it's in dipped only once. and we had our peak value. It dipped once. For the cosine graph, it went up and it came down again. Are you seeing it? We have one value here as the maximum and the minimum. While for the sine, we have the minimum value. Very what? Simple. Now, let's look at the what? The tan graph. The tan graph looks like this. Oh, sorry. It looks like this. These are the tan graph looks like. Please take note of the shape. Oh. Take note of the shape. It's moving from here. Comes out here. Intersect at 0, come out and goes up. So this is the tan graph. That's the tangent graph. The tangent what? Graph. And tangent graph, y is equals to what? Tan what? X. Y is equals to what? Tan x. So we can write tan x here. This is where it's ending. This is where it's starting, tan x. For the sine graph, we started here, so you can write it here, sine x. Sine x. For the cosine graph, we started here, cos x, and ended here. So from here, you move to here, cosine. From here, you move to here, tan, and sine. From here, you move to this point. So please draw this on your notes. You need to know how they look like for the sine graph, for the cosine graph, and for the cos graph. Very important. Now, take note of this. For the sine graph, the key properties, I'll write the key properties for each of them. Let me write the key properties. So that you know for each of them the key properties you need to look out for. I'm supposed to explain it before I clean, but let me write it down. Since it's already on your notes, you look at it. You understand it. Let me just explain it for you. Let me explain it better for you. Alright. For the sine graph, the key properties, you have y is equal to what? Sine x. So the key properties, please take note. 1, it starts from what? For the sine graph, it starts from what? 0. Starts from 0. The what? Maximum is equals to what? 1 at what? 90 degree. Take note. Now, back the maximum is at 90 degree. Then it now go back to 0 at what? 180 what? Degree. I see what I'm saying. Take note of these key properties. Then for the minimum, you know my graph was not drawn to scale, so it might not be accurate in terms of scale, but the diagram is very correct. For the minimum is -1 at what? 270 degree, and what? Complete the circle at 360 degree. So for sine graph, it starts from 0 as it's going, it will get to the maximum at +1. Then it will now go back to 0 at 180 degree. Are you seeing it? That's why we had the sine graph like this. We had 1, we had -1. It's starting from 0. This is the 0 degree, 0 degree. Then they say at maximum we got what? At 1 we got 90 degree. That's the maximum. We went like this. We now went like this. So now this is what? 0 degree. This is what? 360 degree. Understand this sine graph now. At maximum, that is at 1, is what? Went to what? 90 degree. They went back to 0 again. That's at y now, 0 again. Then at 180 degree. Then minimum -1 at 270 degree. I see it. Then ended at what? 360. So this should be what? 360. This should be what? 270. Here should be 270 degree. I see it. -1. Here should be what? 180. I see it. Here should be 180. Then maximum should be what? 90 degree. Alright, so let's go to the next one. The next one, which is the cosine graph. The cosine graph so the cosine graph, I'm turning things to duster. For the cosine graph, key properties for the cosine graph. So for the cosine graph, it starts from 1, goes to what? 0 at what? 90 degree. The minimum is equals to -1 at what? 180 degree. And it now returns to what? 1 at what? 360 degree. I know that cosine y is equal to what? Cos x. And this is how it was for the cosine. Set at 0, went up, came down, then went up again. So this is how the cosine graph was. Set from 0, went up, came down, went up again. Then finally, for the tangent, please take note. I'll be a bit fast so I can call it a night. For the tangent graph key properties. It what? Passes through 0, 0 and is undefined at what? 90 degree and what? 270 degree. Then it repeats every what? 180 degree. So the period is equals to what? 180 what? Degree. And this is how our tan graph looks like. Think from here, and from here. So that's how the tan graph look like, where y is equals to what? Tan x. Alright, so we are done with the graph of trigonometric what? Functions. We are done with the graph of trigonometric functions. So now let us look at the very basic sine rule. Very basic sine rule. Very basic sine rule. And let's also look at the basic cosine rule. Once we look at those two, we are done for today. Basic sine rule and what? Basic cosine rule. Alright, so let me draw two shapes. I'll draw two shapes. And this is for sine rule. This is for what? Cosine rule. I'll be working with them simultaneously because of time. So now, the sine rule, it is used in any triangle. Any triangle at all. You can use the sine rule to what? Relate sides and angles. Please take note of this. The sine rule can be used in any triangle to relate what? Sine and angles, not just in what? Right angle triangle, not just right angled triangle. Please take note of this. You can use the sine rule in any triangle, not just right angle triangle, where this is A, this is C, and this is B. And the angle facing B is small b, that's the side facing B is small b. The side facing the angle C is what? Small c. And the side facing the angle A is what? Small a. Now, for the cosine rule, we use it. Okay, let me draw a shape. For the cosine rule, let's draw a shape. See, almost the same shape. Where is A, where is C, where is what? B, here what? A, here is B, and here is C. Almost the same thing. But the formula will change. Formula is A squared is equals to what? B squared plus C squared minus 2BC cos A, that's the angle A. Now, for the cosine rule, this one, I like the C word, the big C. For the cosine rule, it is used when you know three sides. So before you use it, you must know three sides. 1 and 2. You know two side plus an included angle. Plus an included angle. So now let me explain this. For the sine rule, it's relating angle B, angle A, and angle C with the side C, side A, and side B. It's showing the relationship. It can be used in any triangle, whether it's a right angle triangle, obtuse triangle, isosceles, equilateral, you can use it. But for the cosine, you cannot use it in any triangle. There's a condition or a restriction to it. You must know at least 3 sides. That's either you know A, you know B, and C. It must be given to you. Or you know 2 sides, either A and C, or you know B and C, or you know A and B, and an angle, either you know angle A, or you know angle B, or you know angle C, before you can use the cosine rule. So that is all you need to know on trigonometry. So with this knowledge, I can assure you that if you find any question on trigonometry, you're going to what? Conquer it. You're going to what? Conquer it. So I want to thank everybody for staying to the end of today's class. It was an exciting class, and I'm going to see you same time tomorrow, same venue at Build and Design Academy, 8 o'clock tomorrow. Thank you. Please, in case you're new to this channel, please support the channel by what? Leaving a like and subscribing to the channel. And you can also drop a comment to tell us what you understood in the class, and also tell us any question you have, or in case of any place you do not have a good understanding, let me know. This is my WhatsApp number. You can reach out to me for private lessons and other, just reach out to me for questions. Reach out to me. Thank you.